Let me share my. So this is the last question from the hard bucket. Split array largest sum. We are given with the integer array and we are provided with the integer m, and we have to split this. We have to partition this array into m parts such that uh, the such that we have to minimize the largest sum among these m subarrays. So the main task is to minimize the largest sum of these subarrays, and we have to partition it into m different contiguous subarrays, and the subarray should be non-empty. So it's a simple question of DP, and Puneet will introduce with the approach and solution.
So we have to split
Before
the
we
whole
move
array
forward,
into.
sorry, go ahead.
So we have to split this whole array into two parts in the first example, right?
Yeah.
And then, do we need to concern about the length of each split, or it doesn't matter?
No, the length doesn't matter. The thing only matters is that it should be contiguous subarray, and none of the partition should be empty. And we have to minimize the sum of the subarray.
I see. Okay. Okay.
Fine. So anyone who tried solving it, or like who wants to tell his or her approach? Okay, I guess Puneet, you should take over this problem.
Okay, is the screen visible?
Yeah.
Okay. So what the problem is essentially, let's take an example of the array that taken 7 to 10. 75. So this is the input array, right? And what they have said, they have to split it into two sections such that the maximum of the sums of subarrays is minimum. So what does it mean is, if I split this, so for this array to be split into two, I can, take this one, like I'll just create a different section 7, and then you have 2, 5, 10, and 8. You have 7, 2, and then 5, 10, and 8. So if you look at this one part of the subarray will sum up to 7. The other part will sum up to like 17 plus 8 is 25, right? In this case, the maximum is 25. The next one, you'll have 9 at one side and 23 at the other side. This one has a maximum of 25. So this way, when you have like 7, 2, 5, 10, and 18, different combinations that you create, you'll have this, and then maximum will be 50. So the way that you create these ones, right? And you have to find the minimum of these maximums. So every split will create two sets. In this case, because it's a split of 2. And you have to find the maximum among those. And then among all those maximums, you have to find the minimum. Is that understood as a problem statement?
Yeah. So it's like the brute approach that I can think of. Like we have to make different partitions and then look into the sum of, and which is the minimum.
This is just what the problem is asking about.
Okay. I thought. Okay, fine.
Not the solution. This is just the problem what it's asking about.
Okay.
Is the problem clear till now?
Yeah.
Okay. So let's see how I went through this problem, and probably there may be some better approaches. Actually, there are. Let me just go through the first one which I had. So let's imagine this, you don't have the problem of creating two sets, you have a problem of creating just a single set, right? If you have to create a single set of this one, it's essentially just the sum of all the numbers, right?
Yeah.
Now let's divide the problem into subsets. Now, if I have to find out among the first two ones, what is the sum or the maximum or minimum sum that I can create from these two elements without any split. There's only one set that I have to create. So essentially, till the index I have to only make one set. What will be the sum of that set? If there's only one set, the maximum will be only the sum of those sets, right? Now let's assume
Yes.
I have to use three sets, three characters, which is 7, 2, and now 5. And I had to split this into two different subsets. So what I can do is I can break it here or I can break it here. Is that correct?
Yeah.
Right. Now, if I break it at this position, I know what would it take to create a single set of elements till index I, which I just said before this step, right? We can create this step for all the indexes in the array, which essentially is nothing but the cumulative sum till that index, right?
Can you explain this once more?
Yeah.
Just with the 7 to 5 one.
Yeah, so let's take I equal I here, and then I know I want only one array in that. So let's say I take 0 index. So if I have to take all the elements to 0 index and I only have to create one set, that essentially means anything from starting till this element, right? So what will be the minimum of maximum sums, right? Min of max sums. Essentially, there's only one set, so it will just be the value of the set, right?
Yeah.
Because there are no two sets to compare it with. It's just one set, one value. Same way, if we take index 1 and one set, it is essentially sum of these two elements, first two, just 9. Similarly, if you go to 2, 3, and 4, you'll find you will be creating a cumulative sum array. So now it's
Right.
7, 9, and then 14, and then 24 and 32. Right?
Okay.
So now let's assume that we have this array created. We know that what is the minimum maximum when creating just one set out of it, right? Now let's go to 7 and 2. Right? Now I have to create or I have to find the minimum maximums till index 2 or till index 1. I is here 1, but now I have to create sets as 2. Does it make sense? Is that okay?
Yeah, go ahead. Yeah, go ahead.
So what I can do is to split it out or to create a new set, I can just split it here. There's only one option to split it, right? To create two sets. So the first one is essentially cost, because the last element, anything beyond this will become a new set, right? New contiguous part. So that we can assume we can find the value or sum of the values from the cumulative sum array. Essentially this. So if you have 2 and anything after that, you can take the cumulative sum difference and you will find the sum of this array, right? And for this part, you can take the min of max, which has been already calculated for j minus 1 splits. So in this case, we have two sets. We can already take the minimum or maximum, which has been calculated for one set. So in this case, it will be for 7, it will be 7, comma, what is the cost of remaining is 2. So what is the maximum among these? 7. Now there's no other way to calculate it, right? There's no other split that you can do. So for I equal to 1 and 2 sets, the minimum maximum sets that can be, minimum maximum sums that can be getting is 7. Okay. Now let's take some, next example like 7, 2, and 5. Now I equal to 2 and sets we have to create is 2. Now in this case, you can see we can split it here and we can split it here, right? Let's take the first split. So first split is again 7. Essentially it's this split 7, and the remaining will be I equal to 1 to I equal to 2. And we can use the cumulative sum array to find this total sum, which will essentially again be 7, right? This is okay till now?
Yeah.
And the next split that we can do is this way, right? Now in this one, what we can do is find the minimum maximum that has already been calculated till I, which is I equal to 1 for one set, which is this. We did 1 and 1 is also 7, right? So let's think about it recursively. I'm going to create a new set here, which is essentially just one element. And for the remaining part, I have to split this into again one set, right? Because I have 2 sets total. One I have created here, and the remaining one has to be recursively split into one more set. Essentially, this is just one set, right? There you cannot split it more. So it is 9. So here you have 7, here you have 9. Again, the value for this one finally will be 7. So this way you can go forward and find for every step. Let me just take one example more, which is probably more understanding. You can look it in the recursive way. So if I have to find, let's say this one, I have to find till index 4 of 2, right? Till index 4, there are 2 sets that we have to create. What I can find out is, let's take all the possible, recursion values. So I can take a set from, just split it 7 as 1, and then all the other will be 1, like 2, 5, 10, and 8. This is one set and this one. So this can be represented as earliest, which is whatever has been calculated of 1 for 1, right? And the other set will be cumulative sum from index I equal to 1 to 4, right? Is this clear? This step is clear? Why we are considering this one? Is it clear, or do you need some confusion? Is there some confusion? I can explain it in a different way.
Yeah, it's somewhat clear.
Take not this one. This one will be much easier. Let me try to split this 4, 2 at a position this one, right? So it will be 7, 2, and 5, and then I'll split it at 10 and 8, right? And assume I have to create 3 sets. So what I'm doing is I'm considering the last set is this one. This is one set I am sure of. Now the remaining elements, I have to split them into 2 sets again. This one is clear because I have considered one set as this one, and the remaining I have to create 2 sets. Now let's consider this as a separate problem. 7 to 5, and you have to create 2 sets. The same operation will be allowed. You can, create 3 points where you can split it, or 2 points where you can split it. One will be 7, 2, 5, and the other will be 7, 2, 5. Now, if you consider this one, you will have 7, 7, and the minimum will be 7. Here you will have 9, 5. There will be 9, and the overall will be 7. Now, whatever you do for this one, the minimum maximums will be this, right? First 3 elements, 2 sets, minimum will be always 7. Is that correct, or this is still not clear?
Right. Correct.
So now once you have the solution, you can memorize this solution 7 to 5 for 2 sets, and suppose the answer is 7. Now what you have to do is just take this one, find what is the sum of this one, it is 18, and then try to compare the minimum which is already calculated and the minimum that you can get this time. Right? Sorry, the maximum. These two are, you have to find the maximum among these, which is 18. And for each branch, you will calculate the maximum. So this one may be 7. So the other, this one will be 7, 2. And then you can take 5, 10, and 18 as the last one. This is your last set. And then you have to break this into 2 sets to get this result 4. And you will get some value over here. You will get some value over here, which is like 2, and then you'll get 10. You can take maximum of these two, which will become 10. And for all these branches, you have to take the minimum. Now, if you see this, actually this entire tree will become a recursion tree, which will have a lot of repeats. Just try to create one recursion tree for you. Let's say here, 4, 3, you will have 1, 2 plus cumulative sum from 1 to 4. Other branch will be 2, 2 plus, it's not exactly plus, but the other set, cumulative sum from 2 to 4. Again, going here, it will be 3, 2 plus cumulative sum from 3 to 4. 4, 2 plus cumulative sum from 4 to 4. Now, if you try to split it again, here, you'll get 1, 2 plus cumulative sum from 1, 1 to 2. Right? Now, if you see this structure, it will repeat. And it will repeat for this one also when you expand it to third level. You'll have 1, 2 here, or 1, 1. Right? So this entire thing, you can convert it into a DP equation, or essentially recursion with memorization. Is it clear or not? I know it's a lot of computations and mathematics involved to get to this.
Like I have to sit one thing like with so
Sorry, Ashish was saying I could not hear.
actually I have to do some pen paperwork, so I need some
Yeah,
time.
DPs are usually pain. You have to write it down, create those trees, and to understand. Actually, there's another solution for this. I was just trying to give you idea about my thinking, but there's a binary search solution to this also.
Okay,
So,
like how can you approach for a binary search?
right. So let me clear this out. So you have this 7 to 5, 10, and 18, right? And what you have to do is split it into suppose 3 sets. Or you can easily, they're all contiguous. It has subarrays which are contiguous. So you essentially know you can create 1, 2, and 3, right? But how many elements to take in each of the subarray is something which is, confusing. You don't know, or you have to try all the combinations.
Yeah.
To help you answering that, so if you see, what will be your maximum sum of the subarray? Essentially the sum of all the elements, right?
Yeah, but
and what will be the minimum? Just the minimum value.
Yeah.
So what you can do is just take minimum value,
Okay,
maximum value, take the middle one, and try to see if you can create the number of sets that you are required. Like in this case, 3. Suppose the value is 15. Just example. Now you can, you can cover these two in the first set if you have to go to the maximum of 15. You can cover these two, and you can cover this. So if you have 15, you can reach this, answer 3 if you have a set size of 3 or set size of 15. Correct?
Okay, so it's like binary search plus a greedy thing. Like we have to check.
Right. So every binary value or every value for each subset, you can go and check. And if it is reachable, you'll try to go down. because you have to find the maximum minimum.
Yeah.
Now you can go here and check for this one. If it is not, then you can go up. So that will, kind of, when you move around, you will converge it to some place where you can, which will be the value where you can definitely create the minimum value where you can create the 3 sets, and that will be your answer.
Okay, this is like pretty good. Like,
Yeah, it took me some time. Actually, there's another problem in Leetcode. It was something related to trucks, which I could not remember initially. But later, when I was trying to go through some of the discussion solutions, then I remembered, okay, there was something which I had learned earlier also. So in the initially when I did this question, I did it with DP, which was, it accepted all the cases, but was a bit slow.
yeah, so which one will be more faster, like the binary search or the TP one?
Binary search, definitely. The TPO is actually n square k complexity, whereas this is n log n into log n times. Not log n, it will be log of maximum of.
Because we have to check over here, like if we are getting M pairs or not. So for that, I guess.
Yeah. So what you have to do is take the sum, which is suppose the value is m, and you have to check for each of those n times, which is n elements. So it will be essentially be log of m, n into log of m, where m is the sum of all elements. And assuming that it is always in the range of integer, it cannot be more than 32.
Yeah.
If we consider it's a value between 30, it's a 32-bit integer.
Okay.
Yeah, this didn't come to me initially also. So I also looked at a TP problem, and that's a valid solution. It's just that we can do it in a better way because we have this option of contiguous subarrays.
Yeah. What if we have like subsequence then?
Subsequence. I think then the DP is the only solution, because as far as I remember, calculating a subsequence with some x is an NP complete problem.
Okay. So I guess AP is asking to post the solutions in the Slack channel.
Sorry?
Someone is asking to post the solutions in the Slack channel. So if you
I
have
will post for the hard one.
yeah. Fine. So I guess we are out of time. We have completed an hour.
Yeah, we are actually about time.
Yeah. So let's wrap up. Or anyone who wants to ask some questions or wants to tell something, approach or any variation, something. Or shall we wrap?